Okay. Hello, everyone, and welcome to Handmade Hero, the show where we code complete game live on Twitch. No libraries, no engines, it's just us. And we are in the middle of sort of straightening out our asset story, if you will. Thus far on Handmade Hero, because we've been working on engine stuff, we haven't thought very hard about how we want our assets to actually be stored and loaded in the real shipping version of the game. And so one of the things that we have to do before we can call the sort of underlying layers of the game done is we have to figure out how the assets are going to be stored and how the game talks about those assets so that it can retrieve them and make meaningful use of them. So it knows like what is what, and it knows what to put on the screen where and all these other sorts of things. It needs information about what assets it has available to it. And so that's what we started doing yesterday, just because kind of one thing led to another. We had done asset streaming work, and I was kind of saying, well, in order to go any further on this, we kind of have to have some idea of like what the asset table is and all these other sorts of things. So that is what we're in the middle of doing right now. And so I'm going to go ahead and jump into that. Just before I do, today is day 134, which means that if you are trying to follow along at home and you have pre-ordered the game on handmadehero.org, you will want to unzip day 133 out of the source zip. That is the source code that I am starting with right now, and that is what you should start with if you want to be editing the same code that I am in order to follow along. All right. So if I remember correctly, we only just had gotten started because we were actually working on finishing up some asset streaming stuff yesterday, so we only just barely started talking about the game asset stuff and what we might want to do in terms of how that stuff was organized. We had this concept here of an asset tag and asset bitmap info and an asset group and stuff. The group hadn't really come to fruition much. We hadn't really talked about that very much. But we were kind of saying like, yeah, I don't know about this. It's hard to say. But I wrote kind of a little example routine where I was like, oh, imagine if I had these tags on assets and I wanted to pick, certain assets out of a hat or something like this. This might be the kind of way that I could envision doing it. And so you can kind of see me doing this sort of tag-based matching and weighting thing here to figure out, what would be out of a set, out of a particular set of assets, which of the assets would best match some example where I was saying I want these particular values or whatever, right? And so I don't know how much legs that has. It was just something that I kind of pulled out of thin air. But what I'm trying to do with this and where I'm trying to go with this is I need to have some way for the game to talk about the assets that are in the asset file without actually necessarily knowing what they are. And the reason that I say it that way is because let's say that we want to do something like have some trees, right? We've got trees in the game right now. We have one sprite. It's just a tree, right? And, if I go over here and run the game as it exists at the moment, you can see that there are these little trees that are lining kind of the play area there. We kind of wanted to make like the shape of a room, so we just stuck some trees down there, right? But as we go forward and we want to make more interesting environments, obviously we won't necessarily just want to have one single tree sprite. We might want to have like several trees, right? And we might want to have like forests have different types of trees in them. And furthermore, we might want those forests to have different types of trees depending on where they are in the world, so that there can be different types of trees and different types of forests and all these other sorts of things, right? So you can imagine that there could be a fairly wide notion of what is a tree sprite, even inside just this one game. And so for that reason, we need a way of talking about tree sprites in some way that's different and more expressive than just what I kind of did to simply port what we had right now, which was to just have a single a single token basically that says I want a tree, and the asset system gets me back a tree, right? So what I would rather do is I would rather have something where the asset system can say something like, get me back a tree, and I want a tree with these properties, and I don't really need to know how many tree sprites you have or what their characteristics are. I just know what I'm looking for in terms of a tree, and you give me back something that matches as close as possible what I actually wanted. And the reason that this is kind of nice is it means that without actually changing the game code, you can upgrade the set of visual representations that are possible with the game just by updating the data pack, right? So if Yangshin has only delivered, one tree or 5 trees to me or whatever, and I put them in the data pack and I write the game code, and later we go and see like, oh, we really wish there was a little more variety in this type of forest, right? It's kind of nice to have a system where I don't really have to do any real work in the code to be able to just start adding more tree sprites to it, right? And furthermore, this allows kind of some easy modding to happen as well. It means that if people want to add their own tree sprites to the game engine doesn't have to be recompiled just to allow someone to add some more tree variety or to make trees that are more specific to an area where that didn't actually exist before, right? So that is the idea. All right, that's what we're going for here. So I'm going to go ahead and talk about the easy part of it, and we'll come to the harder part a little bit later. Okay, so if I take a look here into that data directory, right? If we go into the Handmade Hero data directory, we have two things, right? We've got test, where we've kind of got this this stuff where we were starting with originally just the hero and some layer example things like from the startup screen or whatever, right? And then we also have this test 2, which had some variants on things. It had some grasses, it had some grounds, right? And then we had some rocks here, right? And what I kind of want to do is take one of these, which is like the rocks seem to be the most varied, although the trees, I guess the trees we could also kind of do as well if we wanted to. But the trees and the rocks have this sort of thing where I can pretend, even though they're not really set up for it quite yet, but I could pretend that these guys had certain properties, right? Like, for example, this is a rougher rock, this is a smoother rock, and maybe that one's in between, right? And this one's a flat rock, and so on, right? So you can imagine me sort of classifying these guys with some tags that say what their properties are, in addition to the fact that, like, it is a tree, right? And so one way we could potentially consider sort of setting this up is we could think about the tags as sort of having maybe one sort of primal identifier that says what the actual like sort of type of the thing is. This is a tree. And then we could have an additional piece which says here are the tags, which just kind of talk about what the quality of this tree actually is, right? And seemingly for that type, where we have that, the type part, I could also sort of say, we could use that for tags as well, because one thing that you could imagine is, let's say that I have, trying to think of what would be a good example here, but let's say that I have something like the hero. Well, there's 3 or 4 parts to the hero. There's like the hero head, there's the hero torso, and there's the hero cape. And if I think about those pieces, I could imagine maybe wanting those to be subdivided. So I could sort of say, okay, I want a hero. I don't know how many parts a hero has. So I'm just going to trust that you will tell me how many parts a hero has. And those parts themselves could potentially be classified on something, right? And that would be the assembly part of things that we were talking about. So we have a bunch of stuff there. I feel like we want to kind of tackle all that stuff. I feel like it'll be useful for us to tackle that stuff. So I'm going to start with the simplest one, which is just that sort of flavor matching. That sort of, I know that I want a rock, and I need you to sort of find a rock that fits this particular set of criteria. That's what I would like to do first. And so that is what I'm going to try now. Okay. So since we kind of have this, I'm going to go ahead and say we've got a thing here which is, I'll just have rock in here. I'm going to go ahead and add that in. And then what I want to do is say that when I actually go ahead and get out a game asset, when I pull out a game asset like rock, what I'd like to do is I'd like to make it so that that game asset, which I guess in this case, we have this called a game asset slot, and maybe what I kind of want to do instead is just actually go ahead and call that a game asset like so, right? And to some degree, I don't even know if we really need to call it game asset. It could just be called an asset. I mean, there's nothing else in here besides assets, right? I mean, there's nothing else in here besides a game. So it's probably stupid for me to call it a game asset when we kind of all know what it is. Similarly, I could just call this assets, but either way. Or maybe the asset, system manager, who knows, whatever you want. But anyway, we'll leave that aside. We have now this concept of the asset ID that we bring back stuff as, and I'm going to go ahead and say that this is, an assets array, right? Like so. And the assets array is going to be something where this is the sort of the primary word that you use to talk about stuff. So when we say that we want something in the game, we're going to have to say one of these sort of fixed asset ID types, right? We're going to have to say, and I guess, now that I think about it too, maybe these really should be asset type IDs in that sense as well, because we kind of have to say, we kind of have to say which ones. It's not an individual asset, right? It's a particular set class of assets, right? And so we have the assets, and then we also have, in addition to the assets, we kind of have other tables here that mirror the previous tables. So although we were using game asset ID to previously talk about bitmaps, we probably actually want to have, in this here, the asset slot stuff, we probably want to talk about this as like asset slot for bitmaps. We probably want to have that, but we don't actually know how many there are going to be, right? Because we were using the system where we passed around bitmaps by IDs. We still want to be able to do that for asset loading. So really we want to keep that notion around. But now I think what we want to do is have some notion of a bitmap count, right? We want to have some notion of how many there are, and we don't actually know how many there are till we load our asset file. Okay. So we want to do that. And so this is going to be sort of a blind pointer. And so when we go to load the initial asset table off of disk, that is something that we will grab, is all of those bitmap infos in here. And yeah, so we'll get that. Then we'll have the assets, and the assets, of course, in them will have sort of some notion of how to get to that. So we're going to have, yeah, so asset is probably the wrong word. If this is asset type here, right? Then what we're going to have is something like an asset type, it follows off the asset type ID. The asset type will be the thing that we'll actually be looking up into, and that's where we can get out our numbers, right? So we'll basically say, like, here are our asset types. We can pull those out. And once we get an asset type, then inside there, it will tell us all of the options that we have for that particular asset type. That seems pretty reasonable to me. So this would be something, and again, we'll have to go write the usage code to actually know exactly what it's going to be, but I'm just kind of brainstorming out here into the H file to see like what the data is that I actually have. So I would need something like the number of these, right? Like how many I have of a particular asset type, and then I would need some notion of where they all were, right? I'm trying to think now for asset types. I wonder if I actually want to do split these, because there's going to be audio assets and bitmap assets. And I'm trying to think of whether I want them split. I might, even though they're pretty much going to be roughly the same. In other words, we're going to have something that feels something like this, right? We're going to have this sort of thing, right? And so when we go to look up an asset type and we say, I want a rock, the question is, do we have two different asset type tables as well, or do we just have one and they're all in here? So the sounds also come in here too, like hit guy or whatever, right? That sort of thing. So I don't know. I'm not sure exactly what we want to do there. We're only going to be looking up one or the other. But since they're very, very similar, I do wonder if maybe we just want to leave it the same. So I think I'm going to do it that way. I think I'm going to go ahead and actually do it that way. And And maybe I will call this an asset type ID. Maybe I'll do asset type like that. Or I could do AT. I don't know what I want to do for this. It's hard to say. Usually I like to prefix them with something, but I'm not sure exactly what in this particular instance. Asset type backdrop, asset type shadow. Yeah, I could live with that. So anyway, in here where we've got the asset types, that's going to give us something like a count, and then inside there we would need to have some kind of an index into one of the info arrays, right? And there's going to be two different types of info arrays. So yeah, I mean, again, it's unclear in terms of the matching, how we would actually want to do it. But this part is specific to a bitmap, right? But this part isn't. So you could imagine something like, you know, we actually have the asset here. You could imagine something like the asset has the set of tags on it, like so, that sort of conform to that matching stuff that we did. So we have, this is a tag ID, right? This is a tag ID. So we would have up here an asset tag ID. Oh, but that's both are AT. So frustrating. I guess we'll just call these tags, and we'll call these assets. That made the decision for me. That's how we want to do it, I guess. And I won't bother putting in asset type there, I guess, even though that's really what it is. And this is also that. But anyway, so we'll have tags here, and the tags will just be, you know, the stuff that we actually want to put in there. So we can call it smoothness. Was basically what I was saying about the rocks, right? There's a smoothness and then maybe a height, something like that, or flatness. And that would be an example of some tags that we could have on our rocks, right? So yeah, so let's see. If we have those tags on the rocks, we have the asset type IDs. To get the rock out, we could get the rock out by finding one of these assets, which has the tags. And then finally, if those tags match, right, we need to know what we would actually do to get it. And so the final thing that we would need to do there is just whatever the actual ID is into one of the slots, right? So this would be its slot ID. And you would just be required to know which one of these two arrays you were looking up into, bitmaps or sounds, because you're only going to be playing one or the other, so that's really never a danger in my mind. And so that would be roughly the structure that we would have. Okay? So that seems pretty reasonable. So we'd have something like, you know, first asset index and one past last asset index. And this would basically be something that if we wanted to, we could load directly off of disk. Because these are actually fairly, right, these could all be something that we could save directly to disk. And barring endianness conversion, we could actually just load it flat and use it directly, right? So we could do one big flat load and have one sort of giant set of asset information things here, and that would pretty much do it. So let's go ahead and take the bold step. Of going out and making handmade asset.h. And I'm just going to pull this stuff out, and I'm going to put it in here. And again, there's no real reason or rhyme or reason for any of this in terms of why I tend to pull things out in this way. It really just has to do with my mental ability to keep things separated. Sometimes I just like to have stuff come out into separate files so that I don't look at it or think about it when I'm doing other stuff. I kind of put it away in another file, right? And so there really isn't any kind of code reason. As far as I'm concerned, if you can remember it all or your editor is good, unlike, you know, Emacs, maybe it has really good ability to kind of jump around and think about things and view things, then you could just have it all in one CPP file. Like, there really is no reason for H's or anything, or multiple files, unless you really like them for some reason, right? Or your source code controls merge is really lousy. So anyway, if I go ahead and do that, then in the game state, I'm sorry, in the transient state, right? When we have one of these game assets things, it'll sort of store this stuff. We'll expect that to be kind of loaded. And what I'll do in the meantime is I'll kind of pretend that we have a function that loads these guys in, but that doesn't actually load these guys in, right? So, you know, like at startup, where we would go ahead and ask the, platform layer to load in for us a pack file, like, you know, directory kind of structure thing that says all of the stuff that we have. Instead, I'm just going to say, call a function that will create one as if we had loaded it in, so that in the future, when we're ready for that, I can go ahead and replace it with a call to something that actually loads it, right? So let's go ahead and do that. So I want to say trans state, what is this? Assets, right? And so do we must at the moment, actually, because that guy has a sub-arena, right, that it's actually allocating from. So at the moment, we're actually are using that. So I think what I might do, instead of that being embedded, I'm going to go ahead and make it a little clearer about when this happens here, right? I'm going to go ahead and say that game assets, there's like a pointer to it here. And what I'm going to do is right here in transstate, when transstate's getting initialized, I'm going to say that transstate, transstate assets equals allocate game assets or something like this, right? And that'll like load this guy up, and it'll do the sub, it'll do like this sub stuff here and whatever as well, right? So I feel like that should probably, the task stuff should probably come first, because tasks are kind of a primary sort of concept. So those should be in there. I feel like the high priority queue and the low priority queue should also be primary things. So I feel like these guys should be in there as well. The only thing that I'm a little bit nervous about is actually I feel like those maybe should be things that always happen, just all the time. Whether or not the trans state is initialized or not seems like a good idea, meaning this sort of seems like a kind of thing that should always be copied in case during hot loading the queues. Oh, but the queues can't change. Never mind. The queues are not something that change during hot loading, so that's not actually necessary. I take it back. All right, so yeah, that's all good. We got the task stuff set up. We'll allocate the game assets. And in order to allocate the game assets, we would need to pass in a couple things here. And maybe one of the things that we pass in is how big we want that to be. I'm not entirely certain. But let's go ahead and take a look in here. Let's see, in game, handmade assets.h. So in the CPP file, we would have something like allocate game assets, and that returns one of these guys, game assets. And that is going to take one of these arenas, right? Because it's got to do all this stuff. There we go. So game assets, assets, that's going to be a push struct. That's going to go on to whatever arena that we're told to use. And we're going to create one of these. We're also going to take the sub-arena out of that, right? Assets arena, like so. And then this will probably, like I said, be something that we actually pass in here, right? So our trans state arena, megabytes. Our trans state arena is what we want this game assets to allocate from. We want the sort of megabytes here to be 64. That's going to be the size that this thing's going to use. So here's our memory arena. Here's the, I think, what do we call this? We call this a memory index. I don't love that name, but what are you going to do? So we're going to allocate however much it tells us to allocate as our sort of sub-arena for making space for things. And then we need to know a couple quick things about how we're going to do work here, right? And so we need the trans state. So I suppose we will have to pass that in. And we need the debug platform read entire file for now, although hopefully that will be replaced with something else eventually, right? So we have the trans state in there, we got that. So this is the transient state, trans state, and then we have the debug read entire file. Where is my game assets? Where are you? There it is. Couldn't remember the type of this guy. Read entire file. And that should just about do it. That seems good. All right. So let's go ahead and patch up all of the nastiness that this is going to create, having moved that stuff out here. So I'll go ahead and include handmade asset.h, and then in the CPP, I will add in that handmade asset CPP. And then I got to figure out how to sort of calm down all my compiler errors. And let's take a look. Okay, hero bitmaps. I did not actually mean to move that out yet. So why did that get moved out? Oh, because that's here in game assets, right? All right, well, that's fine. Suppose we can move that in here for now, since it's going to become part of this anyway, in sort of the near future. All right, so game asset ID is now an asset type ID, right? So that's fine. Asset type ID. And let's see. So these are technically not going to be game asset IDs anymore. And in fact, really, this load asset is not what we want anymore. So really, we're going to have two of these, right? We're going to have load bitmap and load sound. Those are the two, sort of. I'm not sure what you want to call them. Those are the two audiovisual AV resources we're going to have. So the sound system will call this one when it needs something, and the renderer would call this one when it needs something. And these are not going to be past that. They're simply going to be passed straight up IDs, right? That are, for sounds or for bitmaps that would be looking into the sounds or the bitmap arrays, right? So that's how that actually is going to go. Now I don't actually know, did we move that over yet? I don't think we did. So load asset, right, is in here, and as is the stuff that does the work. So what I'd like to do, I guess, is go ahead and sort of grab that out, and we'll have to grab a few other things out as well. Let's put that in here. So yeah, what we want to do here is take load asset. It is not really load asset, it's load bitmap, right? And it takes the uint32 ID. It does exactly what this does. So this is all still totally what we want. That's all good, right? So nothing particularly needs to change there. And then we would also have, again, a very similar one that would be responsible for pulling a sound out of the sound array. So that's all good too. All right, so when we do push bitmap, again, this is going to be a uint32 ID. That's some bitmap ID that we have. We could, if we wanted to, try to make this a little bit more robust by just introducing a fake type for that. I don't know if we really want to do that or not, but I can show you what that would look like. So, it would just be this, right? Something this straightforward is all I'm talking about. And so this would literally just be, hey, to make sure that people pass these things around typed a little bit more, it's literally just a little bit of installation there, compile time checking to make sure that it doesn't like cast to something automatically, and someone accidentally is trying to specify the height and they end up specifying a bitmap ID, and all everything goes pear-shaped, as they say. So we could do something like that, and then in here we would do a load bitmap call like that. So that's all relatively well and good. And in here, instead of an asset ID, which I think, are we still storing? No, we don't even have to store the asset IDs ever. So that's what it would look like. And then in the load bitmap call, wait, where was that? Was that in handmade.h? Okay, so those should also be moved out as well. Those should be moved out to here, like so. And I can go ahead and move these out a little bit as well. So we have the bitmap ID there. So when we call get bitmap, we're expecting a bitmap ID. There we go. That would get our loaded bitmaps out by the ID value. Okay? So, all right. So let's keep going on the compile errors. So when we do load asset work, instead here, what this is actually is this is load bitmap work. It's not load asset work. It's specifically the thing that loads a bitmap. So it's going to have a bitmap ID. And this is going to be load bitmap work as a function. It goes ahead and uses one of those load bitmap work things, does its little fancy dance here. Debug load bitmap, of course, should also probably be in the asset system now, right? Debug load bitmap. So that should kind of get pulled. Let's pull that out. There we go. Yeah, there it is. And what else we need? Bitmap header has to come in there. There it is. And all right, so what's top down align? Top down align is just something for doing that sort of faux alignment stuff. Okay, so in here when we have to actually use the IDs now, we have to access them because they're actual structs. That's all good. End task with memory and begin task with memory are things that now have to actually have to be called outside. So I don't know where we want to put these exactly. End temporary memory, complete previous writes, task being used. I don't think that needs to be inlined in any particular way. So I'm just going to go ahead and make these be things that we just pull out, like so. Load asset work is now load bitmap work, like we said. And work ID is going to be bitmap ID, like so. Bitmap ID value. And switch ID, it's ID.value again. So these guys are now just asset, right? Guy underscore is asset underscore. So that's not much of a big deal. Load asset work is now load bitmap work. And read entire file is getting passed in here. What is the problem, people? The problem is trans state was not actually supposed to be used there. And I didn't mean to use it, but there you go. So there we have it. First tag index. Okay, so our pick bests thing is not really a function yet, so I'm just going to get rid of that temporarily. Our allocate render group. What is this taking the game assets, right? It needs to take them like that. We've got the grass here. Assets arrow grass is what we actually want. And again, these will all be sort of very soon now be transitioned over. So this is actually kind of not that interesting. But we should, again, want to kind of get everything ported over. So it's worth spending a little extra time to take stuff that, is going to get changed and still ported over just so we can have things running on it. So is it Tran Arena? Yeah. So all of these are assets dot. They should be assets arrow. Yeah. All good. This allocate render group still needs to be changed over. And then all of these guys who are GAI underscore should be asset type underscore. Oh, no. Actually, just asset underscore. My bad. So yeah. So we have a problem here, right? Which is because we haven't quite ported things over yet, these are not bitmap IDs. Actually, so that did just catch the bug that I was saying is why you might want to introduce a bitmap ID, right? I typed that in there not really thinking about it, and that's not a bitmap ID, that's an asset ID, which is like a family of bitmaps potentially. So yeah, that's you know, something to think about. That's all I'm saying. So in this particular circumstance, right, where we're drawing these things, I guess what we need to do is have some way that we can translate just for porting purposes. So we want to do something like, you know, get first bitmap, something like this, where we can talk about, you know, the game assets or something like this, and we'd get the first bitmap ID that was in there. Again, just totally for porting purposes. So it would be something like get first bitmap ID, and then we would pass the game assets, right? So transstate assets, like so. And this would just be something that allows us to do that translation pretty quickly, right? So in here we'd have something like internal bitmap ID, right? And this would be our game assets, and this would be whatever the game asset ID is, so asset type ID. And this would just go ahead and translate that into some sort of bitmap. Now, what we can do, again, at startup is make it so that literally it's just, it is just whatever the asset type ID is, right? We can make the mirror. Oops, that's some spelling right there. So at the outset, we can make it so it's just direct translation, but then we will make it get better as we go, right? And so now what we need to do is just go ahead and translate the rest of these to that, like so. Let's see here, asset like that, like that. There we go. All right. So I think allocate game assets must return a value. You are correct. It must. Oops. I guess the game was still running. I didn't even remember that the game was still running. But apparently it was. Okay, and so now what I want to do is, again, in here I want to create sort of a fake circumstance. I'll come actually back over here first of all to cut out some of the other stuff that was in here, like this asset prep stuff. This is all now stuff that should be in here, right? Loading the bitmaps and all that stuff. So this kind of sets up these things, which will eventually go away. In the asset type table now, what we're going to do in the asset type table, well, actually, I guess we'll just leave that for a second. What we'll do is we'll set up the bitmap and sound count stuff. So we'll just say, okay, the assets bitmap count is going to be equal to the asset count, and the assets bitmaps is going to be a something that's that big, right? So it can hold that many things, right? So we just have that many asset slots there. The same thing would be true of the sounds. But at the moment, we don't have any sounds. Oh, yeah, we have one sound, let's say. We don't actually have one sound. But if we did, we would put it in there. And so that would allocate the table for sounds. And, you know, the asset type array is just the asset type array. And we'll have to deal with that a little bit later on when we get a little further, right? All right. So I think that is sufficient, right? I think that is sufficient. And so right now, this is still switching on basically a totally bogus value because, like I said, we haven't really kind of gotten to the point where we're being a little more thoughtful about it yet. But that's just the way it goes sometimes. What did I do here? Bitmap count, arena, push array. So what is the syntax for push array? Handmade.h, push array, arena. It is the count first and then the type. There we go. Arrgh. What else we got? So thread. The thread thing just seems to have been a complete waste of everyone's time. I had a reason why I was going to do that. And it really just didn't materialize. So I think I may just say that we're going to nuke that. And if we want it, we'll put it back in later. But it's just going to go away. It was a stupid idea to add something before I needed it. That's kind of the opposite of what I always say to do. And unsurprisingly, if you have a rule that's a good rule and you don't actually follow it, you quickly find that you wasted your time. Because you can always go back and add things in, right? And when you go back and add things in, you know how you actually needed them, right? Which is way better than trying to guess how you were going to need them, which is not so useful, right? So yeah, so that was stupid, and we are going to nuke it right now. So where is thread? Thread, comma. It's just getting goodbye everywhere it existed before. It's gone. Nobody loves it. Nobody cares about it. Also, I don't know why I'm even bothering to pass this around, right? So we should probably get rid of that as well, because we already have this notion that we can do these global calls here. So really what we should have done, especially because this is a debug call, is this should have just been a global variable for debug read entire file, right? And then we just delete it later and find all the places that it was called, and then make sure that they're gone. Probably what we should have done a long time ago. So let's take a look. Let's take a look at read entire file. Where is everywhere that that's used? And let us get rid of it. So goodbye to you. You're gone. That's fine. Debug load bitmap is just going to use this directly, right? So this is just debug read entire file. Let's keep on going. Read entire file, debug load bitmap, just takes the file name now. It doesn't take that, right? That's just kind of stupid. So we'll get rid of this, and this, and this. What else? What else? Assets read entire file, goodbye. Read entire file, also goodbye. See, this is how it should have looked in the first place. But sometimes, sometimes you don't clean things up until you should, until you kind of like get sick of it, and then you're like, you know what? This is just a bad idea, let's clean that up. So there we go. Especially with a debug call, it's just not worth the time, right? It's not worth spending your time passing this pointer around for no reason. It's a debug call. You might as well just set it. There's really no point in not doing so, right? I can't really think of a single reason why you would do that. Yet that's what I did. I think they're just sort of like a... I tend to not introduce global variables very often in that sense, and so maybe that's just like kind of residual. Like you tend to not introduce them even maybe sometimes when you should have, but that's another issue, I guess. All right, so anyway, keep going with that. Read entire file. So there's one. Debug entire file, that's good. That is not good. That should go away. That is good. And that is good. Okay, so we're back to, I think, pretty good shape here. So let's go ahead and jump back. Actually, let me jump back to here. So let's now just make sure that we set that. So in handmade.cpp, when we're setting our callbacks, right? Right at the top here, when we set our callbacks up, we just copy them out from here. Yeah, I guess I could call that debug platform read entire file. Debug platform read entire file. And that's a little nicer. All right. So yeah, set top down line, something that should probably have been in here. So let's go ahead and put that in. And there we go. All right, so now thread goes away. There should be no thread. Thread should just be eliminated entirely. So now we've gotten rid of it, so that's all good. Yeah, and now, man, we just did a lot of stuff, so we got to go ahead here and take a look at what we're doing. So those are totally wrong, right? Those are not supposed to be going trans-state assets. Those are just supposed to be straight-up assets, right? Delete, or sorry, kill rectangle. So that's good. Let's see what else we got going on here. Again, wow, we got a lot of trans-state, so we need to get rid of that. So there we go. All right, so that's good. We're back up and running, so that's all fine. Nothing particularly unusual happening there. So yeah, so that's all good. A lot of cleanup today. This is getting good. All right, so we've only got about 13 minutes left. So what I'd like to do is kind of push, see if I can get to sort of the final step of flipping this thing over into the new structure. Not for these other guys here, the array guys yet. We'll tackle those tomorrow. But just for the other guys who are right now just getting translated by the ID directly. So what I want to do is I want to make it so that these guys are kind of loading out of these various file names here. This is going to be totally temporary. Because again, there are not going to be any file names. So yeah, so what I want to do is I want to make it now so that we can actually set up that asset array, which is this got the asset types situation thing, right? And so what I want to do is set up one for each of these guys, and we'll set it up just fake, right? So we can have, you know, backdrop equals assets, and it's going to be backdrop assets asset types, like so. When we grab that out, we can then set that to something. So the asset type backdrop, you can see it has here. What we can say is, you know, we have to obviously introduce an array to store these other things. We have two other things. We have asset tags and assets, right? And so if I go ahead and say I have assets, like so, the asset count, there we have it. And I've got tag count. Now I've got sort of all of the things represented in here that are, you know, that we're kind of saying are part of this asset system. And so I can allocate those. I can say the assets arrow assets is kind of a little bit weird, you have to admit, but I'm not sure. Yeah, I'm not sure what else to do about it, so we'll just leave it that way. So I'm going to go ahead and push on an array of assets here. I happen to want one per bitmap at the moment, so I'm just going to use the bitmap count, right? So that will change when we actually load off disk, but for now we're just going to use however many bitmaps we have. That's how many assets we have. And then the tags, we're not going to actually allocate it all at the moment. So we have tag count, I'm going to say 0, and the tags are also 0. And so those will come in a little bit later. So when we grab a backdrop, the backdrop, right, let's get rid of this. The asset type here, it says how many there are, and where the first one is and where the one past last one is, right? So if I have a backdrop, I'm going to set the count equal to 1. I'm going to set the first asset index equal to, you know, asset index, some kind of rolling value, backdrop 1 past last asset index, is also going to be this. So again, I'm just kind of basically making the database manually here, if that makes sense. Because, you know, until we actually write one to disk, I need something to kind of sit in its place. All right. So one pass last asset index and asset index, those will both be set there. And then I need to do the asset for backdrop. And so I guess I'll do it, I'll do it this way. Type, type, type. And then this will be asset. Asset equals assets plus type first asset index. So we'll take that particular asset. This asset, first tag index is 0. And one pass last tag index is 0. And its slot ID is just going to be whatever its asset index actually was, right? Like so. So that just basically makes, for the backdrop, and I guess I can just go ahead and do this for all of them, right? I can say bitmap ID 0, bitmap ID is less than asset count plus bitmap ID. And so really it's just, I guess I should say asset ID. For each one of these, it's just going to do the type, setting it up one-to-one, right? So nothing particularly interesting happening there, just setting up basically dummy tables for everything. And then I guess I don't even need, right? I don't even need this because we know what it is. So that's all fine as well. Oops, asset ID. Pass last tag index. So that sets up that table. And now, in theory, we should be able to actually implement this function, right? Which is to say that if we have a bitmap ID, we'll say this is the result. It'll be set to 0. We should probably have a null bitmap, now that I think about it, and a null asset, right? You know what I'm saying? That seems like a good idea. So something like asset none. You know what I'm saying? And then the bitmaps, there's also like a dummy bitmap. So I feel like always having 0 being sort of a reserved slot for like nothing is kind of a good idea, right? And in here, we could also do, when you call load bitmap, if for some reason you're trying to load bitmap ID 0, it just doesn't do it. So, if not ID value and, right? So it's basically like saying, I need a valid bitmap ID, otherwise I'm not even going to try to load the bitmap. I'm just going to ignore you when you say to, because we never need to load the null bitmap, right? It's just going to be null. So that seems good. Yeah, that all seems good. So that does that the way we want. So this starts out with the null bitmap there. And then what we'll do is we'll actually try to do the lookup now. So we'll go asset types, right, with the type ID. This gives us back the asset type. And then from that asset type, we can grab the first asset very easily. So, excuse me. So from there we can say, the asset equals the type first asset index. Yeah, so that's assets. So now we've grabbed out the first asset, and then assuming that there actually is any, this thing actually has any at all, because it's possible that there were no assets of this type. But assuming that there were any, then the resulting bitmap value is just the asset slot ID, right? Like wherever that guy is. And that's it. Let's see what happens here. Asset types. What did I do? That's supposed to be that plus. Getting tired. Been a long day. Been a long day. I am going to go out on a limb here, pun intended, and say that we have a problem somewhere, because I don't know about you, but I'm not seeing a lot of trees there, right? Not seeing a lot of trees there. All right, so that's okay. Let's go ahead and step through it and figure out what's going on. Make sure everything is kosher. Looks like, you know, for a type with a particular asset ID, it sets the count to 1. First asset index is whatever the ID is. One past last one. Oh, wait. What? Why is there a count and what? That doesn't make any sense. Why would there be a count and a range? Does anyone know what I was thinking about when we did that? That doesn't make any sense. That's what this is. That doesn't make any sense. I would either have first asset index and a count, or not, right? Yeah, I don't know. All right, that's kind of dumb. We'll pretend we didn't see that, and we'll decide whether we want a count or a one passed a little bit later. We can always change between them. It's not too big a deal, but I don't know why there were multiples of those. So what I wanted to do was actually this, right? I wanted to do if first asset index is not equal to type one past last asset index, right? Then get the thing out. Now that shouldn't have caused our bug at all, but that was just dumb. So we want to get rid of that. So this asset ID, this is so it's one asset ID. That all looks good to me, and yeah, so that all looks fine. All right, so let's go ahead and step into this. Let's take a look at what happens. First of all, let's take a look at the table to make sure that those are reasonable. So here is our assets. Oops. Assets is undefined. Something tells me we need to switch to the debug build. The compiler can't find anything. Well, the debugger can't find it, but probably because the compiler didn't tell it where it was. All right, so if we take a look in here, we've got 7 bitmaps and 7 assets. That's what we wanted, essentially. And in the asset table, oops, that's not what I wanted. In the asset types table, right, first asset index, one past last. So these kind of go up as they should. In the assets, first tag index, let's see what it looks like if we take a look at all of these, right? Slot ID, first tag index, one past last tag index, that's all fine. And the slot IDs look like they roughly go 0, 1, 2, 3, 4, 5, 6. So they do reference the bitmaps properly, I would think. So that seems okay. Let's see what happens when we actually try to get one of these guys, which is get first bitmap ID. So let's see what happens. We come in here, we're asking for a tree. So we pull out the one that corresponds to tree. First asset index is 3, one past last is 4, right? They are not equal, so that's good. We grab out an asset. What is the asset? The asset has a slot ID of 3, so we set the result value. So what does that actually equal? That's a value of 3. And that is, I assume, what we actually would expect it to be. And it is, because they're lined up at the moment. So we go ahead and get that. That's good. We go into push bitmap. Push bitmap is going to call get bitmap with that function, right? It should return null because we haven't loaded it yet. And we should ask to load it. So we come in here. If not ID value, which should be true, oh, no, it shouldn't be not ID value. It should be ID value. Oh yeah, it has been a long day. All right, that's probably the bug. One would assume. Yep. That was the problem. It is true. Let's make sure we didn't have... I guess we should double check, make sure we don't have any weird performance things going on there, because we were running it in the other mode. It was nice and zippy. Yeah, it looks nice and zippy. All right, so that's good. We got all that stuff set up. So now we are properly going through that indirection, which means now we can start to actually use that indirection on tomorrow's stream, which will be good. So I think that's good. We're starting to get a little bit of a database structure here to things where we can kind of, essentially have our own version of, a query, if you will, where we can say, hey, I need you to get me back asset that follows this criteria. It'll do a match. It'll come back to us. And so we're getting there. We got a little bit further to go, but we're getting there. All right, so why don't we go ahead and go to the Q&A, like so. This way. All right, so if anyone has any questions about what we're doing, please go ahead and put a Q colon in front of it and type it in so I can see it. And please keep it to stuff that we are doing so that it's kind of something that's on topic. And while I wait, I might do one really quick thing that somebody pointed out. Well, actually, I'll just do the Q&A. And if we have extra time in the Q&A, I'll go do one more thing. Let's see. Abner Coimbre, you won't be using any formal database for the game, correct? Why? So the reason why is they're actually quite complicated, right? Because there are many, many reasons why a formal database, like something that would be like a SQL database, right, or something, would not be useful for the game. And it's kind of difficult to cover what they all are. But it all kind of boils down to the fact that we have a very specific way in which we want to retrieve things. And it's very easy for us to code that by hand in a way that is very fast. And to know that if we need to get more sort of acceleration out of it, that we can custom build it around the one kind of query that we do. Whereas if you use a database that's something off the shelf, you are constantly trying to shoehorn your access pattern into its semantics. And it really just causes all of these headaches for you that you wouldn't otherwise have. And so, and a lot of the things that a database does for you, like atomic operations or distributed storage and all these other things, we can't take advantage of. So you're basically just accepting a huge amount of risk and gaining basically nothing back, right? And so, that's the sort of short part of it. But the longer part is actually a lot more in depth. There's a lot. I actually studied databases for a long time. I've written my own databases. I wrote a game that runs on databases entirely. And so I have a lot to say about that, but it is not something that can even fit in like the whole Q&A. It would kind of have to be like a very long series of talks about like, here's what databases do and don't do and don't understand, and here is why they're bad for things, and here is what would be better, and that sort of stuff. But for this particular case, I think a lot of that stuff is not necessary to understand. It's not even necessary to understand databases. It's simply a case of them having far too much bulk and far too much domain mismatch for the case that we're trying to do. And so while you could try to implement something like a weighted tag match on top of a database, you would basically be fighting it to get the performance you probably could have just gotten by writing it yourself in not that much time. Like the amount of time you'd probably spend dealing with it over the course of the product, would make it so that you really you were getting a net loss as opposed to just implementing yourself. So this is not a case like sometimes on Handmade Hero, with like the bitmap loading code or something, right? Sometimes on Handmade Hero, we write something ourselves just because the idea is to show how to write things from scratch. That's what we're doing. It's educational, right? In this case, I'm not writing this myself to be educational. I'm writing this myself because we actually need it. A database would not serve our purposes very well, if that makes sense. And it's just because there's just a really big mismatch between what it does and what we do and how much it does and how much we need it to do. Is there any way I can download these episodes to watch on the go? Yes, absolutely. If you would like to download them, if you go to handmadehero.org, you can go to the forums button, and if you open up that forums page, there is a code discussion forum here. In the code discussion forum, there is a downloading videos using BitTorrent sync option. And as you can see, Martins, who is actually kind of a ninja, he answers everyone's questions on the forums. I don't actually know what he does for a living, but he must be a very knowledgeable coder. It seems like he's always answering people's questions before I even see them. But he basically set up a BitTorrent sync, and what I do is I send the raw videos to Martins, and he puts them on his BitTorrent sync. So those are actually even better than the ones you can get on YouTube because they've never been recompressed. They're direct recordings from OBS. So if you do want to download them, you can do this. I believe Martins keeps it up to date, but I don't know because I don't actually have BitTorrent sync, so I'm not sure what the status is, but I believe that's the most efficient way to do it. Why code is C as opposed to Java? So we're doing basically low-level educational programming where we show how everything works. And Java runs through a VM and is garbage collected and blah, 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 blah. So that's not really a very good language to teach how to program a CPU. Java is too abstract for our purposes, would basically be the way to say it. Assets include compressed sprite sheets, audio, video, and bone rigs. Yes, if we were going to have those. We will probably not have bone rigs or video. We will have sprite sheets and audio, because since our animation is going to be procedural as much as possible, there's never going to be an animator actually rigging and animating things. We kind of have to do that in code, if that makes sense. But if you had an animator who was making bone rigs, then they would be an asset which you could choose to put in the asset system. You wouldn't necessarily have to. You could choose to make all bone rigs be a resident thing that gets loaded at startup or something if you want to, but yeah, I mean, typically I would put them in there so they can get streamed in and out in case they're large or whatever. Any more questions? Well, since there are no questions at the moment, I'm going to do something that someone brought up on the stream. It's a very minor thing, but I thought it was interesting, so I kind of wanted to address it, if that made sense. So here we go. So if you recall all the way back to when we very first started programming, the first week or something, what we have, we've got the sort of hot code loading stuff that works, so you can you don't have to reload the game to change the code. You can just change the code while it's running. And that's cool, but we had a thing that I kind of vacillated about, if you remember, and it was is initialized. And basically what I said was, well, should we pass is initialized in, or should the game just look at the first byte of the permanent storage, and if it's 0, then it knows that it wasn't initialized, and so then it should set it to true, right? And I didn't really have a strong way of doing it either way, so I was just all right, we'll just do it this way. And I think I said, well, this way it could force the game to reinitialize or something, or I don't know. I didn't have a good reason one way or the other. What somebody pointed out on the forums was that technically we currently have a bug. It's not a bug in the actual game, but it's a bug in our sort of debug system, right? Which is that since we allow that looped live recording, if you hit the looped live recording start before the game has actually even ever been called once, then it will record the zeroed out memory, call the game will initialize itself and it will go, right? Then later when you hit the loop point, it will go back and properly initialize everything to 0 by loading it off of disk, but is initialized will still be set to true because that never gets changed. Which means that there's technically a bug there, which is that, the game thinks it's initialized, but it wasn't, and it'll crash or something, right? So that means it is much better to make the other architectural decision than the one I made, which is that this should not be passed in. And it should simply be incumbent on the game to have its own isInitialized that's baked into its actual data, so that if it restores a zeroed out version, it will work, right? So that's like way better. So now we know. And that's the reason I wanted to cover that, was like, because that's sort of exactly the kind of programming that I like. We had an architecture session, we didn't know what decision to make, so we just made one. Later on, we've got actual real data about a real bug, and we haven't seen anything else to suggest that our old way was somehow better. So now we totally know how this should work. Like, we kind of know the right way now, because we have a proof positive bug that happens because of the way we chose to do it, that we would have to work around. Whereas if we just done it the other architectural way, it would have just worked, right? So basically this, right? This is what we wanted. And that's way better, right? And so yeah, so that's like a better way to do it. And now I believe, I'm not 100% certain. Oops, what did I do there? Actually, also, how did that compile? Is-initialized. Oh, okay, because it just lets it be set to 0 by default. Yeah, okay, that makes sense. All right, so hold on a second. Let me get this working properly. So this looks at memory permanent storage. It looks to see if game state is initialized. It should be if not initialized. Right, there we go. And off we go. So I think that correctly fixes the bug. Again, not a bug in the game, but bug in the debug layer. And I think it sort of definitively answers that architectural question. And so I just wanted to bring that up. All right, so there we go. How on earth do you procedurally generate character movement? You would be very surprised at how much you can do with procedural character movement. I will point you to a fantastic example of it. I guess I don't know if you guys know him. There's a fellow named David Rosen. He made, well, he kind of started the Humble Bundle, I think, actually, I want to say, with some people. But he runs Wolfire Games, and he made like Lugaru and he like Overgrowth he's working on now. But if you take a look here, he gave a talk, which hopefully the GDC vault will let out of its secret vault long enough for you to watch it. Oh, cool. It looks like maybe he posted it. So if you watch this, I think that will give you an idea of just how much animation you can do without ever actually having any real art happen. He uses a couple keyframes, but like only a very few keyframes. And you'd be kind of shocked at how much animation he gets out of them, and it looks pretty decent too. So I would check that out if you're interested in it, but you know, we'll be doing it later on the stream. So can you run clock again? I always forget how to run it. Is it clock handmade code? Is that how you do it? I think that's it. Yeah, we're getting up to the 10K mark. It's crawling up there. I'm not sure how big the game would be when it ships. It's a good question. Hopefully not too large. You want to try and keep your code kind of tiny, you know? So yeah. Have you ever used Unity 3D? No, I have not. What advice do you have for relatively new programmers who are trying to ditch the OOP mindset and move on to things like data-oriented design and compression-oriented design. So the advice that I would have depends on the person. So if you are somebody who learned to program and then learned object-oriented programming and it messed you up, then what I would say is just go back to the old way you programmed and start again from there. That's what I did, and it works really well. And just focus on sort of programming the old school way where you just sat down and tried to get something to work, and then add on to that the compression-oriented steps where you go like, oh, okay, now I'm going to pull some stuff out, and now I'm going to try and make some things that, like, you know, are repeatable things that I see myself doing often. I'm going to make repeatable pieces out of those, right? But if you're somebody who never learned how to program on their own and was taught OOP first, then I'm afraid I don't know, since I've never been in that position myself, I don't know what the right thing to say is. I think what I would say is try to put the notion of the programming language out of your brain and try to think about the computer. What does the computer need to do to solve the problem that you have, right? What are the literal steps that the CPU must do to solve the problem? Write that as simply as possible. That is the foundation of coding. And everything that is structural, language-wise, that builds up should build up from that and not lose sight of that, right? And so that's just something that people who learn to program by themselves without anyone ever telling them about object-oriented programming, that's what they naturally did, because when you naturally sit down and try to learn to program and you're just kind of like hacking around on a machine and just kind of poking at it, you always are coming from that mindset. When you were learning, you were like, oh, I want the computer to like put a red dot here. How do I do that? And that's what you were thinking. But in your brain, you weren't thinking like, oh, do I need to like abstract the concept of a screen, and red, should red be an object that, oh, what is this? Is the pixel an object, or is it a group of objects? Is there a container? Do I have to ask a factory to get me a color and that color is red? You know, like all of those things just weren't in your head. So you learned how to program the right way first. And then what happened is when you started getting up into things where your programs were pretty big, and you were like, I need ways to manage this, then you like kind of found OOP or something, and it kind of ruined everything, right? And so what you want to do is just try to get up to that point right before the OOP ruining, throw away the OOP, and realize that that first part was all correct. You don't need to rethink it. You actually were doing exactly the right thing. The only thing that you need to do is change the way you do your higher level organization. Don't think about OOP. Instead, just think about how can we reuse little chunks of this code, right? And when you start thinking about that, you just naturally pull out the pieces that are reusable, and those pieces then can have pieces that are pulled out that are reusable, right? And again, you just compress, 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 right? And it's not like it's magic. You can't just do it. You have to like practice that too and learn all of the different ways you can try to compress things. But that is the right way to do it. And then that way, you don't have to think about objects. You don't have to think about those sorts of things, or sort of these really kind of extraneous concepts that really don't have that much to do with programming. And instead, you'll see that the closely related forms, the parts of OOP that worked at all, which are not many, but the parts that did, will naturally arise. You don't have to plan for them. You don't have to plan for objects anymore. Objects will naturally appear because they are the pieces that, as they got compressed, they were the thing that sort of encapsulated the data that this thing needed to work, right? And so you can even arrive at the same, like basically the same program even, sometimes from an object-oriented mindset and a compression-oriented mindset. The difference is the compression-oriented mindset took a ton of the work out of it, right? But most of the time you end up in very different places. But that's good, because usually the OOP place is a bad place. And the cop place is a good place, right? But yeah. And so that's the thing. And again, I want to emphasize that like object-oriented programming, the problem with it is not the concept that there could be an object, right? The problem is the fact that you're orienting your programming. It's exactly what it says, object-oriented programming. It's the object-oriented, the whole word, that's the problem, right? An object may not be a problem. Like, it's not a problem if an object suddenly appears in your code, like, oh my god, I gotta get rid of this object. This is a disaster, right? Because data gets bundled all the time, right? That was before object-oriented programming as a concept ever occurred. Data got bundled. And there are algorithms which operate on the data, and you could choose to link those two things together. You could do all sorts of things, right? And so the problem with object-oriented programming is the fact that you are orienting the thinking around the objects, not the functions. That's the problem, right? So it's the orientation that's bad about it, not whether you end up with an object. And that's a really important distinction to understand, because it's I don't want people to get in this habit of thinking that, oh, if I ended up with a bundle of data, somehow that was bad, because that's not bad. Data does get bundled together. It's a way of reducing the number of things that you have to talk about in a particular piece of code, right? And so where the problems start to come in is all the sort of object orientation start, where you start to say, like, oh, things have to be objects which are always encapsulated, and they have private member functions, which are the only things, not private member functions that can operate on their private data, which are the only things that are allowed to do that, and that's important. Like, all of that stuff is actually not important. That's like bad ideas, right? And so you want to get rid of those, but you don't want to necessarily get rid of the concept that you might have bundles of data and there's functions that kind of go along with those in a sort of way that you maybe say, okay, I'm going to sort of put this aside as a library or something like that, right? Because C libraries still exist, and the C library is not object-oriented by any stretch of the imagination, but it has something like a time structure that has day, month, and year, and it has some functions that operate on that, right? And the difference is that the functions are primal, and they can operate across many different types of things. They don't have any particular adherence to any sort of like, oh, I'm a friend of this, or I can only access the private of this, or oh, we've got to pass messages around, or any of this sort of things, right? They just have certain bundles that they do use to talk about, and those bundles are units of information that we found to be convenient rather than having to pass everything in and everything out all the time, right? And so hopefully that gives a little bit of perspective on how those sorts of things shake out. And what is and is not important in the various models, right? All right, looks like we're all done. No more questions? Looks like we got no more questions. All right, so I will go ahead and wrap things up. Let's close down here. Doop. Doop. All right. Let's see. And what was our clock? 7,400, I guess. Does it actually say how many are... Oh, that's the actual lines of code. I see, but there's comments and other things. So the actual total number is these like added together if you just want actual lines. Wait. Oh. I guess I don't understand. So why does this say 76,000 lines? Oh, that's the speed. That always gets me. All right. Never mind. All right, now we can wrap it up. Thank you, everyone, for joining me for another episode of Handmade Hero. It's been a pleasure coding with you, as always. If you would like to follow along with the code, you can always pre-order the game at handmadehero.org, and it comes with the source code, so if you would like to follow along with the source code and play around with it at home, you can always do that by pre-ordering the game. I upload it every night so that you can use the latest one the next day. We also have, if you go to handmadehero.org, a Patreon page you subscribe to if you want to support the video series. There's a forum site you can go to ask questions or get ports to Mac and Linux, look at an annotated episode guide, other good things like that. There's a tweet bot you can use if you want to know like when the stream's going to be live. It tweets the schedule and that sort of stuff. And then finally, we also have a little Live Now button that was contributed. Basically, it says when, there's like a countdown timer till the next stream. So if you're just curious how long it's going to be till we're on again, you can always check that out too. So check all that stuff out. It's all pretty useful. Yeah, until tomorrow, we'll be back here 5 p.m. Pacific Daylight Time tomorrow to do a little bit more work on the asset system. I hope to see you all there. And hopefully, yeah, we'll maybe do a little bit of that tag matching, see how that system kind of works, see how we like it, and make some decisions about where we want to go from there. So thanks everyone for joining me, and until next time, happy coding.